In this video, we're going to be going over radiation example problems that you might see on the test. Most of the questions that we're going to see are probably going to be more conceptual questions, but there may be some questions like this that have to do with a little bit with math. So we're going to do some examples. There are some strategies, so I want to go over those first. When an element goes through alpha decay, that alpha particle, remember we could draw the alpha particle with an alpha symbol, or we could draw it like a helium nucleus. So we got a couple options there. When an element goes through beta decay, we can write that like a beta, or we can write it like an electron, because beta decay is when it shoots off a high energy electron. Or positron emission is a beta particle that's positively charged, or we could think of it as a positron, like an electron that's positively charged. So it could be written either of those ways. And then electron capture doesn't release a particle, so I'm not going to write it down here, but it would just be like an electron that gets captured. So we could write it similar to an electron that gets captured, which would be an E minus. But when we are doing these problems, we want to think of how the nucleus is changing. So we can think of the atomic number as kind of the positive charge of a nucleus and how the positive charge of that nucleus is changing. And we could think of the mass number as how the mass is changing. So ways that we would write this in these problems, or we could write these to help us solve these problems, are alpha particle stays exactly the same. Because our beta decay, our beta decay decreases our protons in our nucleus, it decreases our atomic number. We can write it down mathematically like this, because it's decreasing our atomic number by 1, and it has a mass number of 0. Our positron would be an atomic number of 1, so we have that positive charge leaving, and it has a mass number of 0. And we would just write the electron capture in our equations. It would be just like an electron. So these aren't necessarily how you write the particles out, but it helps us with the math that we're going to see in these problems. So I want to make that clear. This is how they would be written out in chemistry. This just helps us with the math. So a question might look like, what does polonium-210 become after going through alpha decay? So what we're going to do is we got polonium on one side, and it's going through alpha decay, and it's becoming a completely different element. So we're trying to figure out what this element is here. So when we say polonium-210, we know the mass is 210. And now we have to figure out what the atomic number of polonium is. So this is, again, where you're going to have to bust out your periodic table. Look for polonium. And you could see it is has a mass number of 84. And then what's important to solve these problems, and it's why we can use these symbols to help us with the math, is that on both sides of this arrow, our atomic numbers, or we could think of these as nucleus charges right now, have to equal each other. And on the top, the mass numbers have to equal each other. So 84 is equal to 2 plus 82. And then 210 is equal to 4 plus 206. So I can use this 82 to figure out what element this is becoming. And if I look on the periodic table, atomic number 82 would be lead, Pb. And that would be my answer right there. So we'll be doing 5 of these questions. So we'll have some time to start seeing the patterns. Oh, this question is slightly different. What type of decay occurs when cesium-137 becomes barium-137? So here we start off with cesium-137. Remember, that number is going to be the mass number. And it is becoming barium-137. So the mass number hasn't changed. So I could even say the mass number, because that hasn't changed going from cesium to barium, whatever particle gets shot off is going to have a mass number of 0. So we know already it's not alpha decay. And then if we take a look at this, we're trying to figure out our atomic numbers here now. So for cesium, if we take a look, cesium has an atomic number of 55. And barium, right next to cesium, has an atomic number of 56. So our protons in our nucleus are going from 55 to 56, meaning that we need to have a negative charge getting shot out in the form of a beta particle. Another way you could write this would be like that. So the question is, what type of decay occurs when cesium-137 becomes barium-137? And the answer would be beta decay. All right, going into another question. What does magnesium-23 become after going through positron emission? So we got magnesium-23. So that's where we put the mass number. And we could use a periodic table to figure out the atomic number is 12. And it's going through positron emission. So you can have this in your notebook. Remember, positron emission is going to look like this in these math equations, 1 and 0, because that proton's becoming a neutron. So you're losing the amount of protons in our nucleus, and that charge is getting shot out. And the question is, what does that become? So we're looking for what is this right here. So the mass number is going to stay the same. And to get our atomic number of our new atom that's being made, we need 12 equals 1 plus 11. So it's going to be the element with an atomic number of 11. So it's going to be sodium. So that is how we solve this. Again, we just have to make sure that we take a look at the arrow. All the numbers on the top, when added together, have to equal all the numbers on the left. And all the numbers on the bottom, when added together, have to equal the number on the left. Or all the numbers on the bottom, on the right side, have to equal all the numbers on the bottom on the left side. So that would be our answer for our third question. Moving into our fourth question, what does krypton 81 become after electron capture? So electron capture is different because it's not getting shot out, it's getting captured. So for this one, when we see electron capture, we're going to have krypton 81 and remember, we can write electron capture like this because it's just like it's capturing an electron, which is decreasing our atomic number and keeping our mass number the same. And it's becoming something else. So I want you guys to be very clear. When we are doing electron capture, our electron is on the left side of our arrow. For our alpha decay, our positron emission, and our beta decay, our particle was on the right side. But because electron capture is getting captured, it is going to be on the left side. It's not getting emitted. So we'll have to find the atomic number of krypton. By the periodic table, we take a look over here, Kr, atomic number 36. And that's everything we need to know to solve this question. So 81 plus 0 is equal to 81. So that atomic, or that mass number stays the same. 36 plus negative 1, so 36 minus 1 is going to be equal to 35. And we could figure out what element this is. Atomic number 35 would be bromine. So we got bromine 81. And that is our answer. And we got one last question to go over. What is the product when carbon-14 goes through beta decay? So we know it's beta decay. And we start with carbon-14. So carbon-14 goes on what we start with. And we should have this memorized by now, but if you don't, we could look at the periodic table. And our atomic number for carbon is 6. So if you need to review it, carbon, atomic number is 6. And it's going through beta decay. So remember, beta decay is something that gets shot out. It's going to be a product. It's going to be on this side. So we can write our beta decay like this because it is a negative charge getting shot out, so it's increasing our amount of protons. And then we just have to figure out what it's becoming. So 14 equals 0 plus 14, so the mass number stays the same. And then 6 equals negative 1 plus 7. So that would be nitrogen. And then if you have to double check, we can come over here, and atomic number 7 is nitrogen. So when the question is, what is the product when carbon-14 goes through beta decay? Our answer would be nitrogen 14.